All right, welcome everyone. Today we're covering the AMDM Unit 3 Statistics Test Review. Let's start with question 1. It says, what are the steps in the research cycle? And there are 5 steps. 1, you want to identify a question. You want to design your study. You want to collect data. You want to analyze the data, and then report the results. So once again, question, design, collect, analyze, and report. Make sure you know all 5 of these for the test. All right, number 2, explain the difference between primary and secondary data. Primary data are data that you collect directly, and secondary data are data that has been collected by someone else. Number 3, explain the difference between an observational study and an experimental study. An observational study collects data about some characteristic of the population. Experimental study is where the researcher separates participants and applies a treatment. The variable of interest is measured and results are compared. All right, here is 4, 5, and 6. Looking at study number 1. A linguist studying sign language has participants watch a video of various signs while in an MRI machine in order to observe if there is a difference in brain activity when actual signs are performed and when random motions are performed. The participants are people with little or no knowledge of sign language. So question 4 says, is this an experimental study or an observational study? This is observational. And then question 5, if observational, which it is, what variable is being observed? Well, the variable being observed is brain activity when signs are performed. And here's number 6. If the linguist sends out a mass email to students at her university asking for volunteers, what kind of sampling method is she using? Well, she is using convenient sampling, and that's because the researcher has easy access to the university students. All right, here is 7 through 13. Study number 2. A nutritionist wants to know the effects of eating fish on hair health. For 1 month, she asks 100 volunteers to not eat any fish, and she takes samples of hair at the end. Then for another month, she provides them with a fish meal 3 times a week and takes hair samples at the end of the month. Is this experimental or observational? This is definitely experimental since a treatment is applied to a group of people. Number 8. Since this is experimental, what are the treatment and variable of interest, and what are the control and experimental groups? All right, well, the treatment is eating fish. The variable of interest is hair health, because that's what you're observing. And the control group is the first month volunteers who were not eating fish. The experimental group is the second month volunteers who were eating fish. All right, and number 9, what would be a possible hypothesis for this study? Well, the null hypothesis is what the researcher believes to be true, and that is null hypothesis equals H0, and that is eating fish causes hair to be healthier. That's your null. Then the alternate is the opposite of that. The alternate, which is HA, is eating fish does not cause hair to be healthier. Number 10, explain the difference between a null hypothesis and an alternate hypothesis. And a null hypothesis states that what is claimed is actually true. The alternate hypothesis states that what is claimed is different from what is actually true. Number 11, name 3 groups of people who need special protection in research studies and explain why. One group would be pregnant women. There is a fetus that could be affected by the study. And then there's 2 more groups that kind of go together. You'd have children and you have mentally disabled. those groups may not fully understand what they are agreeing to. Number 12, how could excluding certain people from research studies be dangerous? We may never learn about a group if it is excluded. For example, if children are excluded from medical research, we won't know whether a new medicine will help or harm them. Number 13, explain what is meant by informed consent and why is this important? Well, informed consent is the legal procedure of informing participants of procedures, risks, and benefits of a study. It is important because participants need that information to decide if they want to participate. It also protects the researcher from lawsuits. Number 15, explain what is meant by saying that a politician's popularity is 67 plus or minus 4%. Well, this means that the popularity is actually 67%, but with a margin of error of 4%. If you subtract 4% from 67, you'll get 63. And if you add 4% to 67, you get 71. So that means that the actual range is between 63 to 71%. All right, number 16, match the definition with the appropriate sampling method in the list below. All right, it says, number 1, the researcher chooses the sample from the entire population through a randomized technique. That is going to be simple random sampling. So number 1 is D. Okay, number 2, the researcher separates the population into evenly sized groups, randomly selects one participant in the first group, and then selects every nth participant. That's going to be systematic sampling. So that would be B for number 2. Number 3, the researcher separates the population into a number of subpopulations called strata, and then takes a random sample within each subpopulation. That is going to be stratified random sampling. That's A. Number 4, the researcher selects participants based on easy access or easy accessibility, and that's going to be convenient sampling, E. And then number 5, the researcher separates the population into groups and then randomly selects some of these groups to participate, and that's going to be cluster sampling. So number 5 is C. All right, here's number 18. It says draw a histogram for each of the columns of data below. Be sure to label the axes and use a calculator. All right, in the first column, it looks like we have 10th grade GPA. First, we'll notice that we have one number that's in the 60s. We've got 4 numbers in the 70s. We've got 1, 2, 3 in the 80s. And we've got 1, 2 in the 90s. All right, so we'll use that information to do our histogram. So as we said earlier, we have 1 that's in the 60s. So you have your first column would go from 60 to 69 and the height of 1. We said we had 4 numbers in the 70s. And so you have the next column going up to a height of 4 and ranging from 70 to 79. And in the third column, we had 3 of those in the 80s. That's from 80 to 89. And in the last category is the 90s, and there were 2 of those. Notice that we labeled the x-axis as 10th grade GPA, and on the y-axis is 1 to 4. So there's your histogram. The numbers you see here are SX, which is the standard deviation, and this is your 5-number summary. All of this was done on the calculator, and you should remember how to do that, and if you don't, let us know and we'll be able to help you with that. All right, on the right you have 12th grade GPA, so let's look at that information. Do it the same way. We had 2 numbers in the 60s. We have 2 numbers in the 70s. We have 3 numbers in the 80s. And we have 3 numbers in the 90s. And The axis is labeled as 12th grade GPA on the bottom and 1 to 4 on the side. The numbers you see here are SX is 10.94. That's the standard deviation for 12th grade. And then you have the 5-number summary. Again, all of this is done on the calculator, and you'll definitely have to do this on the test. So let us know if you need help with that. Okay, number 20. Is the data quantitative or categorical? Explain. Well, the data is definitely quantitative because it's GPA, and GPA is numerical. Number 21, draw a box and whisker plot for each column of data on the same number line. All right, so first we draw a number line and we go from 65 all the way up to 100 because none of the numbers are as low as 65. I think the lowest one is here at 67, and they don't go all the way up to 100. So 65 to 100 was a good way to label the x-axis there. All right, this first box and whisker plot is for the 10th grade. The minimum was 67, that's the first line. Quartile 1 is 75, that's where this line is. The median is 79, that's where this line is. Quartile 3 is 89, and that's where this bar is. And then the maximum is 95, and that's where this bar is. Now let's bring in the 12th grade box and whisker plot. For the 12th grade, minimum is 68, and that's about where that line is. Quartile 1 is 76, which is here. The median is 83.5, which is here. Quartile 3 is 91, which is here. And the maximum is 98, which is here. All right, that's your box and whisker plots for both 10th grade and 12th grade. And then number 22, which data set has more variability? Explain. Well, the variability is described by the standard deviation. So the 10th grade standard deviation was 8.73, and the 12th grade standard deviation was 10.94. So we just write those down here at the bottom. And because the 12th grade has a higher standard deviation, we can say the following. The 12th grade GPA is more variable because it has a higher standard deviation. All right, 23 says match the following types of bias to each scenario. So let's read the scenarios and then match the biases. A group of rowdy seniors notice that a principal is watching their class from outside the door. The seniors immediately settle down and begin paying attention to their teacher. Well, because the principal was watching them and they settled down, that is observer effect. So A is number 4. All right, here's B. Researchers want to find out how the residents of Roswell feel about the local recreation areas. The researchers decide to question only the members of a local country club and find that 90% of the population is dissatisfied with the recreation area. All right, well, that is going to be non-representation of the population, because if you're only asking the people of the local country club, you're not getting a good representation of the Roswell population. So that is non-representation of the population. Right? C. In order to gauge the effectiveness of a coaching staff, the head coach asked several of his athletes to complete a survey about his coaching methods. The answer choices to several of the questions were extremely satisfied, somewhat satisfied, neutral, and slightly dissatisfied. And that is definitely response bias. First of all, the responses were controlled, and you notice that there's no response that says extremely dissatisfied. So there is a response bias there. D. A medical researcher gives an elderly woman sugar pills, but tells her that she is taking an effective medication to help her insomnia. In a follow-up interview, the woman claims that she is sleeping through the night with the help of the pills. When we talked about that in class, and that is definitely the placebo effect. It's pills that don't have any active ingredients, but psychologically you think something is actually being effective. So that's the placebo effect. All right, here's E. While trying to gain support for a tax increase, a survey company questioned several residents of Roswell. The company asked the question, in order to ensure your child's future is bright and full of opportunity, do you think we should raise the current tax rate? That is definitely E. That is definitely wording of the question. It is worded in such a way that you want to answer in the affirmative of raising the tax rate. It makes it sound like you're doing it to benefit your child's future. All right, so E is number 3, wording of question. All right, and then the last one. During the most recent elections, a local magazine mailed a survey to several of its readers. The overwhelming majority of responders stated that they supported the Democratic candidate. If every reader had responded to the survey, the magazine would have been able to accurately report that the Republican candidate had a higher number of supporters. And that is definitely number 2, and that is non-response bias. Because not every reader responded. As a matter of fact, apparently several of the Republicans did not respond. All right, number 24. Part A, draw a histogram with low statistical bias and high variability. Now, for it to be low statistical bias, the population mean would have to be near the middle of the data. And for high variability, the data would appear to be spread out. So let's draw a histogram where the mean is in the middle or near the middle, but the data appears to be spread out. It could look like this. So we're stating the population mean is somewhere in the middle, and you see how we have everything is kind of spread out, and there's a lot of variability with the heights of the bars. Okay, and then B, draw a histogram with high statistical bias and low variability. So if it's high statistical bias, the population mean would be considerably higher than the data, and the data is not spread out because that has low variability. Okay, so high statistical bias means the mean is either higher or it could be even lower than the data. And low variability means the data is not spread out. So we could draw something like this, where the population mean is definitely above all of the data. And then here the data is kind of close together. It is not spread out at all. All right. Well, that concludes the Unit 3 review. Hope that you study well, prepare well, and a lot of the information that you see on this review, you will see again on the test.